Welcome, data science leaders. Today I'm going to talk to you approach. Take them and dunk them into whatever data visualization software, whatever tooling that your organization prefers. So I have successfully, when I was a grad student, I used to teach high schoolers. And I would take these high school kids, and in under a week, I would replace all their Excel skills with one of these two. And if high schoolers can do it under a week, so can all those people who claim to be not data people in your companies. Now, the trick is the tough love of when they squeal and say it hurts, you say to them, no, just go look it up, go look up some sample code and modify that a little bit. You don't need a PhD to be doing that, but you need to kind of socialize that idea a little. So if you're looking at digital photographs, you're already doing data analysis. Just do more of that. Next tip. It's all good and well that you want to empower everyone in your organization to start having a look. You need the data to look at. And unfortunately, folks, knowledge is power, and people realize that. In large organizations, especially, people start acting strategically and optimizing maybe a little bit for their team and not for the greater company in which they are embedded. And so they might hoard information because, oh goodness, if someone else looked at it, it might make them look bad. And it's really difficult to incentivize them individually to share information. Because look, not all the information that you have is this stuff about users that's governed by privacy regulations. It's not stuff that you can't for legal or competitive reasons release. A lot of it is about how your company operates and how decisions are made and the information that people are effectively using. But that ends up just on somebody's spreadsheet, on somebody's laptop locally, and it never gets shared anywhere. And there's no real incentive to share it unless you make this cultural. unless you teach your organizations that everybody should be sharing any data that they can share, that there's no good reason not to share, and allowing everybody else to look at it. Because yes, sometimes something will come up where you see something that another team is doing that might not be the best idea, but then as an organization you can improve. So we at Google give a lot of our internal data, of course not the user data, but things, for example, like our employee databases to everybody. And we also give the tooling so that someone in human resources or lawyers can just have a look at that data to see things like in which month are people most likely to leave the company? When are they getting hired? Basic things like that. No reason not to share it. In which teams is there attrition? Then, tip number 3. Inspiration is cheap, but rigor is expensive. See, when it comes to a photograph, by looking at what is here, what do you learn? Well, exactly and precisely only what is here. Nothing beyond that photograph. And once you learn what is here, you get facts. Those are good if you needed them for decision making. Maybe you get inspiration. So imagine you see some photograph. I'm inspired by this fashion example from the talk before. So you see a photograph, let's say, taken at a sports game. I went to Duke for one of my graduate degrees, and Duke's colors are blue and white. So let's imagine a photograph of lots of people wearing blue and white. You pick up this photograph, what can you say? Well, here in this photograph, there's a large proportion of blue and white. You can't just leap beyond the data to say something like, we should now start selling blue and white t-shirts. They will be what's hot on Milan's catwalk later in the year. That makes absolutely no sense. You shouldn't be leaping beyond in this way. Now, there's some kind of weird belief that if you just math real hard at a data set, you can pull something more out of it. And you can turn that fraction of blue and white thing into some intelligent statement about the rest of the world. There is no magic that can do that. All you can say is that this is what is here. Now, if you're going to be using data for decision-making beyond that data set, that's an Icarus-like leap. You could hurt yourself if you do it wrong. And what you should realize is that if you just inherited some data set somewhere and you had no control over how it was collected and how you were going to ask and answer questions based on it, that's like walking down the street, stumbling upon a photograph with a bunch of people wearing blue and white, picking it up, and then learning something about the rest of the world. You don't know anything about where that photograph was taken. You don't know why it was taken that way. And you don't know who photoshopped it. Because frankly, folks, the best analogy for data science, I'm afraid to tell you, is Photoshop. There's some very benign and very useful things one can do with Photoshop, like, I don't know, visualize what is here, for example. But you can also tell whatever story you feel like telling with it. I mean, why are my travel photographs where I go to very touristy places full of people, they look like it's just me in this landmark? That's because there's a way to take that photograph to create that data set. There's a way to snip, snip, snip around it. And even a way to cut some things out or merge or change things so that it looks like how we want it to look. And so if you find this photograph lying on the side of the road, the only thing that you can learn about it is what is here. And that might be inspiring. Inspiration is amazing. I'm not saying don't get inspired by data. Teach your organizations to do that. It's wonderful. But to go beyond it, that is expensive. And that takes the right approach and the right skills. Now you actually need experts to do it. Now, when thinking about data science, these words are used so loosely. And if we don't agree what we're talking about, then we might end up fighting for no good reason. So I'd like to propose that we look at data science and its subcomponents, which I'm going to pick here as descriptive analytics, statistical inference, and machine learning. That's how I and Google see this. I propose that we don't look at this from the perspective of algorithms, because frankly, if you are smart, you can use the same algorithm for any one of these. You can use a neural network for getting inspired, sure, why not? And you can do something super clever with a bunch of t-tests that can be the basis for a machine learning system, also why not? So let's separate them based on how we're actually going to use them for decision making, for actually getting things done. Now, I'm all about decision making because I believe it doesn't matter what we think we know while we keep it to ourselves and don't let it influence our actions in the world. What we know only matters when we act, when it changes the way that we interact with the rest of the world. So I like to look at things from the point of view of decision making, and from that point of view, let's see, how many decisions are we making? That's what we might ask. If the answer is none, get inspired, that's descriptive analytics. If the answer is one or a few important decisions with no do-overs, statistical inference, or statistics for short, and then many small decisions, automating decision making, that's machine learning. So I propose this little flowchart for helping folks that you work with figure out where you want to be going. So first question should always be, are we making decisions? And if the answer is no, go to descriptive analytics. What do you want to do? You want to simply visualize what is here. Look at a bunch of photographs. You got a whole pile of photographs, you're not making any decisions. What's the purpose? Okay, let's get inspired. How do we do that? Just look at it as quickly as possible. That's the game. Now, say we are making decisions. Can we just look up the answer? Is the decision based on something like, does there exist a red thing in this pile of photographs? If yes, go left. If no, go right. Well, look through the photographs and see if there's the red thing. Still descriptive analytics, this is where we're dealing with facts. And you don't need a PhD to do this. This is just all about visualizing the data. I mean, people are already doing this with Google Photos or Microsoft Paint or whatever else. And all the common sense stuff that they bring to the table because they know how to deal with photographs, they should just be bringing to all these other data types, but it is the same thing. Now, say we can't look up the answer. Now we're dealing with uncertainty. Next question is how many decisions? And if the answer is many, machine learning. We want to automate decision making. We want to use this pile of photographs to come up with a recipe or strategy, model, for dealing with new photographs, new data situations. Now, say we have only a few. The next question is, are we scared? Does it matter? Do we need to control the risk? Or do we have healthy bank accounts, and our question is, should we buy a blue or white t-shirt? If we're not scared, and it doesn't matter that much, back to descriptive analytics. It doesn't matter enough to do it rigorously and properly, so just go with your gut, because who cares? You do not want to be wasting a PhD's time on whether you should buy that blue t-shirt. But say it does matter. Now here's a situation in which it might matter. You have just built a machine learning system to automate decision making. And it's going to automate some part of what your company does. And if it goes wrong, you're going to lose a lot of money. Now that seems like an important decision where you kind of care that this machine learning system actually works, but your launch, not launch decision is a one-time thing. Okay, for that then, you're going to need statistical inference. Does it actually meet requirements? And statistical inference is what allows you to come to conclusions safely. So there's always a bit of confusion. On the one hand, people like myself are saying, hey, you don't need to be an expert to look at data, just go for it, have fun, enjoy yourself. And on the other hand, you keep hearing, you need experts, you need top talent, you need these PhDs. It confuses people to hear that mixed message. Well, look, what you need all those trained statistical thinkers for is for coming to conclusions. If you're willing to just get inspired, to just look at what is here and treat it the way that you treat a photograph, don't take yourselves too seriously, then you actually only need people who can pull it up and have a look. But if you wish to come to conclusions, then you need help coming to conclusions safely. And then you need the experts. And so what you can do is actually do a little bit of reshifting of approach and effort in your organizations where it's not important to come to conclusions. Let everyone have at it. And don't bully them about whether or not they have the credentials. Just teach them how to visualize data and off they go. Essentially how to use Microsoft Paint, except now that's called Python or R, or whatever else you like. But you're going to need the experts if you want to do more. Just realizing that inspiration is cheap, rigor is expensive, that leap beyond your data, that's the Icarus-like leap. And you need to make sure those wings work if you're going to do it. And it's really, really cheap to just get a lot done without needing those experts. All you have to do is promise that nobody takes themselves too seriously. Just like everyone in your organization already knows that when they see an advertisement with whatever they see in it, happy, smiley, perfect-looking people, for example, they shouldn't take that too seriously and learn too much from it. And similarly, when they look at data in your organization, just having that small piece of mental discipline. So, key idea. Descriptive analytics, just looking at the data, everyone should be empowered to do it. And no one should be told, you don't have the credentials, get out. Everyone should get started today. Going beyond the data, though, that takes expertise. So, say you wish to go beyond the data. Now you come to stage 2. Uh-oh, no experts. So, problem here is not knowing how to hire the right talent, and also that, let's face it, the job market today is a little bit in favor of the talent because they know what they're worth. But what helps leaders is knowing what you need, knowing what you're buying and what to look for. And so here's a little bit of advice from me. It's all opinion-based, so take it with a grain of salt. But I'd like to take you on a roles safari of what I think are the most important hires in a data science, a data-driven project. And this is in terms of who has to be there first and in what order. So here we go. Number 1 is the decision maker, the leader. And not just any leader, the leader that knows their craft for this area. That means trained leaders. And the kind of minimal, let's say, personality attribute that you want here is the deep thinker who actually thinks about what it takes to get them to act one way or another. What are their decisions based on? How do they want to integrate information? Once you have this person in place, next is your ability to get data in the first place. And if we're talking at scale, then this is really hard. If it's not at scale, then maybe it might be your data engineering is just pulling up a spreadsheet, right? But it's about getting all the data. If you don't have any data, then what do you need any of the other roles for? Number 3, your basic descriptive analyst. And the good news is that everyone in your company is already this. And I know it might feel a little weird, data science team leaders, that I'm saying that you shouldn't be limiting this to your function. And you're like, oh dear. But a lot of what we do is this. Now you're saying everyone else in the organization should do it. And there's plenty of good things that you will want to do, and you will find that your own value grows as the rest of the company is doing the basic stuff. So for your basic descriptive analyst, you kind of just want someone who is not data phobic, who thinks data might be pretty, and who's willing to just plot some things. And having any conversations about whether it's right or wrong is as weird and irrelevant as asking whether or not you're looking at a photograph you found on the side of the street correctly or incorrectly. I mean, that's not an argument that you have with one another, right? You shouldn't be having that argument for this role either. Next is your expert descriptive analyst. They are lightning fast, so they can just surf through your whole data, all your data sets really, really quickly. And they're about plotting all the things. Now, I had a realization surprisingly late in my career, which once I saw it, was so obvious in hindsight. Maybe you've all seen it already, but just in case you haven't, the person you want to hire for this role should not be a good programmer. Not a reliable software engineer. Why? Because the reliable software engineer is too slow. Someone who understands why you mustn't call your variables x1, x2, x3, x4, and is worrying so much about whether or not their code is going to be reproducible, will do something beautiful and look at that much of your data sets, while someone sloppy would have already run around in your data and actually found directions that might be worth pursuing. You want to encourage speed. Now, the kind of funny thing here, then, is that if we don't recognize that there is a special expertise to being fast and writing code that, let's call them real software engineers, writing code that would offend a real software engineer, if we don't recognize that this is its own skill, then we get into a situation in an organization where you have the software engineers bullying these folks, telling them that they are bad at their jobs. The job is to be fast. That is a special set of skills. And those are skills that you have to train for. How to be as quick as possible in getting through as much of the data as possible. And there is as much merit in that skill in a world that's generating so much data so quickly as there is in writing these big, reliable, carefully crafted systems. So you should stop any kind of bullying that is happening in your organizations by engineers who are telling the folks who prioritize speed that actually this is not a real engineer right here. That's not going to help your culture of getting inspiration from data quickly. Okay, your next hire then. So you have all these people running about in the data, sloppily looking at photographs, and it's all fun, and the only rule is don't come to conclusions, and hopefully they're not coming to conclusions, except that human nature is to come to conclusions beyond the data. It's really hard to restrain that impulse. And so sometimes you need the spoil sport. So my primary training is as a statistician, so I tease my kind, say that we are the people who come and rain on the parade and say, well, you know, this thing that you're so excited about, it actually doesn't hold up for these 20 reasons. This is about coming to conclusions safely and cautiously, and when it matters. Now, you also don't want these folks to be doing every single project, because for many projects, there's no need to come to conclusions safely. They are quite slow, they slow things down. But if they are good, what they produce, you could think of it as the real deal. So where it matters, you need folks keeping you safe. Number 6 is the AI or machine learning engineer. This is not the researcher who builds the algorithms. This is the person who effectively shoves a whole lot of data from large data sets through a lot of software packages, and then looks at what comes out on the other side and sees if that's kind of promising or not. So this is all about making it work. And a funny thing here is the personality that's not good at this. Can you think of it? The perfectionist. The perfectionist makes themselves and everyone around them really sad, because what the perfectionist wants to do is go to the textbook, read in the textbook whether it is going to be a decision tree or support vector machine that I need right here for this data set, get it right first time, run the data through it first time, then it works, and then off we go. Now, it's nice that they want to agonize so much about getting it right first time, but the thing is, someone who doesn't know what they're doing, doesn't know what any of these packages do, but can just shove data through them really quickly and see how the performance is on new data on the other side, that person is going to outperform the first one. And so what I tell our machine learning engineers when we're training them, so I'm the author of our biggest data science training program also, and I've trained over 17,000 of us in it. So the machine learning engineer folks, they will, when they're getting started, they're like, okay, so tell me, should it be this one I must use, or should it be that one, or should it be this other one? And I have to keep reminding them, wrong question, folks. Tell me how long it will take for you to try them all. Okay, this one is 3 weeks, that's 5 minutes, that's 2 minutes. Look, these two over here, you could have tried them instead of having a conversation with me. Then you could have known if they're promising and you should iterate on them, because this is very iterative. Just try a whole bunch of things, see what works. So perfectionists need to have their perfectionism encouraged out of them here for this. Next one is what I call the data scientist. You find on people's job applications, data science sometimes means only 1 or 2 out of the previous 3, but the way that I like to use the word, it means mastery of all 3. An expert, lightning-fast descriptive analyst who is also well-trained in statistics, who is also pretty good at machine learning engineering. This person is my number 7 suggested hire for you, because it is really expensive to get 3 in 1. In this market, it might just be easier to get them separately. But if you can get one, if you are one, know your value. This is a valuable hire right here. Even more of a valuable unicorn is the transcended data scientist, the data science manager who suddenly wakes up one day and realizes maybe I should do things that are useful rather than just fancy, yeah? And so this is the person who can connect the decision-making side with the data science side, all of you. And so I like to joke, if you find one of these, grab them, pay them whatever they want, and never let them go. Number 9 is the qualitative expert. What is this person for? This is a social scientist, typically. I'm going to talk about them later. But this is someone who assists your decision maker. If your decision maker doesn't actually know the craft, what they're supposed to do, this is a person who can help the decision maker think through setting up the problem. What are they actually asking for? Why do they want what they want? Because that social science training is a little stronger at that part of the game than the mathematical or even business management trainings. And then number 10 is the researcher. If you actually know that everything that's available for you out there, all those packages, aren't going to produce what you need, well, then you'll have to build it yourself in-house, some new kind of neural network architecture. But this shouldn't be your first hire unless you know you're going to need that. And how do you know you're going to need that if you haven't even looked at your data yet? Now, what I see instead, too many businesses end up trying to staff their entire team with a bunch of PhD researchers. And what these folks want to do is research, not solve business problems. And they don't even know what they don't know. This is a hire that you only need in a few cases, not everywhere all the time. So that's why they're in my number 10 position here. If you are a research organization, I was part of Google's machine learning research group, then you need researchers, you need those PhDs, of course. But if you're just growing out a business, it won't be your first, most immediate need. So key ideas here. Experience and attitude are much, much more important than education or formal training. And the best, most important hire, without whom don't even bother, is the leader who knows their role. So let's talk more about that then. You've hired a bunch of people, a lot of experts. Maybe you've hired researchers and data scientists. And the non-data science leadership of your organization says, what's the point of these people? How experts are useless. They're just sitting in a room making white papers. What's the good of this? Or even better, someone actually said to me, maybe a year ago, said, Cassie, do you think data science is a bubble? Well, see, actually, maybe it is. It is a bubble if we don't figure out data science leadership. And if what happens is all the experts go in a room and sit together and don't do anything useful. There's no value to it if it's not valuable, right? Tautologies. So the problem is this. The solution is leadership. Trained decision makers who know their craft. And how our environments shape us. If you've never taken any kind of mathematical course, what you might tend to do is worship mathematics and think it's magic that makes, I don't know, certainty out of uncertainty, something out of nothing. The laws of common sense don't apply to it. That's some kind of bad thinking. But say you go all in on the mathematics and you spend your whole life in that. You might be guilty of some bad thinking as well. See, think about this. You can get pigeons to peck at keys to play a song, right? How do you do it? By reinforcing them, giving them what they crave over and over on a nice long reinforcement schedule. So it occurred to me that somebody who spends willingly 20 years in academia is doing that because they find something reinforcing, maybe the gold stars that they get from academia. And where does your gold star come from? It comes from doing the most complicated thing in your arsenal at any given point in time. So what are we reinforcing in our PhD-trained folk? Not the useful behavior, the complicated behavior. Of all the tools I have right now, which one is the most complicated? And so when they leave academia, what do you think they're going to do? The most complicated thing possible at any given point in time. And maybe you didn't need that. Maybe you just needed someone to look at it. You'll get inspired and you move on with your lives, and that takes 3 minutes. But instead, we've got some crazy neural networks-based whatever. And when we hire a team that is entirely data science folks, by what mechanism were we expecting people to exit from this default comfortable behavior and start understanding impact and start understanding usefulness and the business? So in the talk before mine, it was a very good point about how it would be great if the data science function were involved in framing the context and figuring out what's useful. I'm all for that. But you've got to train them to be able to do that. Where does the training come from? If all you've done your whole life is the most complicated math possible, how do you know about usefulness? Right? Now, a trained decision maker, part of their job should be that, understanding what is worth doing in the first place. And so I submit to you another cultural hack for your consideration. Maybe don't let the mathy folks kick off the rigor. Maybe instead, let the decision makers figure out whether the problem, the issue, is actually important enough. And so, let everyone be sloppy and look at photographs until a decision maker says, whoa, 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 actually this is important, and I am scared, and I want to do this properly. And then they will orient the project correctly, and they will get the experts to put the right amount of rigor into it. Of course, that means we need to train our leaders in understanding how to work with data science and how to think about their role. So again, inspiration is cheap, and that should be the thing you default to. You only need rigor if you need rigor. And you know, I was proposing this idea to a group of data scientists recently, and one of them said, but this is hard for me, because I feel like I need to save the decision makers. Like, I'm rescuing them. I'm saving them from themselves. Now look, if you are actually better at their role than they are, you might be right. But are you, though? Do you have the training to be better at that role? Right now, this whole game is based on hope. And site reliability engineers at Google, that's a function that keeps our large-scale systems safe, their motto is, hope is not a strategy. I love that motto. Hope that you train a bunch of people in mathematics, sciences, and then have them transcend and actually get the business, and that leadership will come out of this transcension process, that is hope, and that is not a strategy. We need to start building training programs to actually teach leadership how to do their part. And I'm heartened and amazed and delighted to see so many of you in this room who have transcended. You have defied the odds. Because you shouldn't be here, right? You shouldn't exist because no one trained you. You just at some point realized that usefulness was kind of important. You'd studied something else entirely, and then, because you were good, you went and you learned what you were missing. You first realized, I'm missing some skills, I'm missing some stuff. What are all these other disciplines I have to borrow from to retrain myself? And then you became that transcended thinker. But was there a plan to turn you into that? And was there a plan to generate a workforce that can cope with that? There isn't. And actually, that is my core passion at Google. I come from a very interdisciplinary background. My areas of study are statistics, machine learning, psychology, economics, and neuroscience, and so the decision sciences. And so from that perspective, I had a little bit of these extra views that might be missing if I just focused only on statistics. And I realized that there is no plan. And to get the training that I have, you have to take a whole lot of things that are completely useless, actually, for doing this function in business. There's no training program that will get it for you efficiently, and so that's what I did at Google. I built that. We call it decision intelligence engineering. You can think of it as avoiding type 3 error. Statisticians, you know your errors, you know what type 3 error is? What's type 1 error? Incorrectly rejecting the null hypothesis. Type 2 error. Incorrectly failing to reject the null hypothesis. Type 3 error. Correctly rejecting the wrong null hypothesis. In other words, using all the right math to answer entirely the wrong question. So training in how to cope with all three of those errors. So this decision-making component, it's hard. You need to get help. Where can you get help? Well, I suggest if you are a decision maker who isn't trained in any of these things and you haven't gone and supplemented your own knowledge, hire a helper, a metrics specialist. They are very undervalued right now. Social science actually trains them to think about how they want to operationalize their metrics, what they're actually studying, what they're missing by defining something in a particular way. Or you might hire a hybrid decision maker, so a data scientist plus a decision maker. So get help from those social sciences. There are a whole lot of areas of study where your entire PhD program focuses pretty much on incentive design and operationalization and what you're asking. And really thinking through what could go wrong and how the data might be biased. That's not stuff that you learn in a mathematical statistics program. I've taken some of each, so let me tell you, I did not get mine in my stats. So hire a helper, but also consider getting help from the data. You already know that if you use a data set for getting inspired, if you look at it, you have burned it for rigorous decision making. That p-value does not mean what it's supposed to mean anymore. Because the p-value is all about like, whoa, am I surprised? Well, I'm not surprised if I asked the question that was driven by the data set in the first place, right? We'll talk about this later. The point is, though, that you can use a data set for inspiration or rigor, but never both. So what's the quick fix? Take one data set, turn it into more than one data set. Splitting your data is how you have your cake and eat it too. And I don't think that this message is spread enough within organizations right now. Now that there's more data, this having your cake and eating it too is a quick fix that is cheap. It used to be expensive when it was hard enough to scrape together one respectably sized data set. But now that everyone's got a whole bunch of it, what's your excuse for not splitting? And so what you end up doing then is lock everybody out of a data set where we plan to come to conclusions and take ourselves seriously, and let everyone in the organization explore the rest. And what they're really going to do, and you know, put a bounty on fun insights that lead a decision maker to act. Why not? Give people time off or a bonus or something if they succeed at getting something out of the data that actually causes action. And then everyone is baiting a hook, and they are flinging that hook into the ocean where decision makers are swimming, and decision makers swim around this tasty insight nugget. Usually they ignore it and make decisions some other way. That's par for the course, you know this. But every now and then a decision maker swims real close and bites and wants to use that plot or that statement of statistical significance or whatever else to drive a decision. Then instead of letting them potentially hurt themselves, if it's an important decision, you say, 1 second, decision maker, let's actually check that you should do this. And then you bring the other data set and you use it as the safety net to make sure that it hasn't just been a case of finding Elvis's face in a piece of toast, which is what first speaker of the day talked about. How it's really, really easy to find nonsense in data, because if you just keep looking and looking and looking, you'll find all kinds of things that look compelling. Well, make sure that they're actually holding up elsewhere where you didn't get to look for Elvis's face. Look on another piece of toast. Is that face still there? And there are creative ways to split. You already know this one, split at random. But there's also this other one. How about grow your exploratory data gradually? Just look, ask if you're inspired, and if you're not inspired, take a few more data points, take a few more data points. And in my experience, if you get through half your data and you're still not inspired, it wasn't promising for all of it. Of course, splitting on time, and then splitting the way that pilot studies in academia do it. All the data I have today, let's have a look at it, and if there's something really promising and worth doing, then let's promise to collect data tomorrow. So this is about taking a deep breath and just allowing yourselves to have fun, enjoy, look, get inspired, but don't take yourself seriously unless you've done the extra bit, and for that you need a fresh data set. So rigor starts with the decision maker, and splitting your data is a cheap way to have your cake and eat it too. And then finally, let's move past the last stage, data nonsense. This one. Don't even bother coming to the meeting without data. Look, this is about, if a company worships data so much that everyone has to have data just to battle it out, that to me looks like people bringing photoshopped photographs to a meeting, and the more Photoshop you've done, the more of a, I don't know, big gorilla you get to be, the scarier the math is. And so then the data scientists are being used by leadership to just have a big old fight who can do the more complicated thing to prop somebody else up. First, delegate decision responsibility appropriately. That's the first fix. But the second fix is understanding that there's a difference between data-inspired and data-driven. When you look at information, you have killed your ability to use that to drive your decision. If I show you this, 4.2 stars, would you stay at this hotel? You are not going to use that 4.2 to drive the decision. Your decision's already made based on whether you want to stay there or not. And the way that you will interact with that information will produce the way that you then ask the question, get the answer. So if you wanted to stay at this hotel, you'll be like, yeah, 4.2 is bigger than 4.0, that's why I'll stay there. statistically significantly? Or if you didn't want to stay there, what am I, an animal to stay at a hotel that's got less than 4.5 stars? And the way that you picked that depended on what you wanted the outcome to be. And you see this in this simple situation. And somehow, when you start adding mathematical complexity and you spend, 2 years of 200 statisticians finally coming with bleeding knees, producing the number, here's 4.2, and then decision makers will look at it and go, let me figure out after the fact how I even want to ask my question, you've just wasted a bunch of time. And so your protection then is realizing that there's a difference between data-driven and data-inspired, allowing people to be inspired by data. But if you wish for the data to actually drive your decision, you need to preset the decision conditions, frame the context before you begin. And so you can use exploratory data to get inspired, frame that decision context. And then the new data set, where you can't cherry pick how you're going to ask the question, to actually compare your framed context with what the data say and allow the data to push the decision. And so this is about training decision makers to actually know their craft. And in the last minute before you go to lunch, this is about knowing that the order you deal with things is dealing first with what am I going to do if I have no new information. That means saying what I'm going to do by default. Am I going to launch this system or not? Be honest with yourselves. And if you have no preferred default, there is no need for statistical inference. Statistics is the science of changing your mind. And if your mind's not set, go with what's in the data directly. Don't do anything fancy. Then, once you've got your default action, under which circumstances, if I had any information I wanted, would I want to do it versus not do it? So that means really framing what information you need, how you want to measure things, doing the metrics design, setting up the criteria. Quick tip for you here. Don't name your metrics beforehand. Don't say, we're going to do this all about user happiness, now how do we measure user happiness? Then you have to follow 2,000 years of philosophy. And at the end, you'll end up with the wrong KPI anyway. Instead, measure what you actually need to measure. Name it whatever you want afterwards. Happiness or blork-de-bork, doesn't matter. No one needs to have a monopoly in which thing is actually user happiness. Measure whatever you need to measure. It's up to the decision maker to solve your business problem. And then finally, if you can't get the facts, if you don't have the full information, you only have partial information, bring in the statistician, and now talk about how much risk you're willing to take of being wrong. Because, hey, with uncertainty, you can be wrong. There is no magic that makes certainty out of uncertainty. And people think that they can hire a statistician to do that for them. They're wrong. Let them know at the beginning that that's never going to happen. And so, yeah, last tip, actually think about what's in your photograph and how it relates to what you're after. If you have only a partial view, where did that partial view come from? Is it sensible to leap from a photograph taken at a sports game to Milan's catwalk? Maybe not. And so key ideas are that there is an order to framing the decision context. It has to do with dealing with information, and social science folks who are trained in disciplines like behavioral economics know about this stuff already, so if you don't know it, hire them, they can help you. And then after that, you're at stage 5, data-driven. Congratulations. So whose organizations are data-driven? The data drives your decision-making. Any survivors? I think we can all be better. And I hope that I've inspired you to start thinking about how we can all be better and thinking about joining me in a quest to move towards decision intelligence. Data science plus, as I like to think of it. So thanks so much. I've run out of time, so I'm going to be hanging out. You can come ask me your questions. I will go hang out where there's food, so you can eat and ask me your questions. But I think I have to send you to lunch, right? So thank you very much.